world's air traffic control system still uses components defined in the 1940s following the establishment of the International Civil Aviation Organization. This traditional ATC system uses analog radio systems for aircraft communications, navigation, and surveillance, also called CNS. CNS is a major factor in determining separation standards, the distance one aircraft must be separated by another. Separation standards determines the number of airplanes that can occupy a certain volume of airspace. When aircraft are flown under radar control, the controller sees the airplanes in the control area and can issue timely corrective directions to multiple aircraft. As a result, the separation standards can be less, but when outside of radar control, it's a different story. In areas, oceanic or land, which do not have radar, ATC is unable to rely on controllers to see problems. Without this surveillance capability, the separation standard is determined by the speed and accuracy of the remaining components, communication, and navigation. Aircraft inertial navigation systems can drift significantly. Communications via HF radio can be very slow, suffer from poor voice quality, and operators can be oversaturated with requests. These procedures require greater separation between aircraft. ATC's ability to monitor aircraft was being rapidly outpaced by the growth of flight as a mode of travel. So in 1983, ICAO established a special committee on the Future Air Navigation System, or FANS, to develop operational concepts for the future of air traffic management. The FANS report laid the basis for the industry's future strategy for air traffic management through digital CNS using satellites and data links. Work then started on the development of the technical standards needed to realize the FANS concept. In the early 1990s, Boeing announced a first-generation FANS product known as FANS 1 and implemented it into the flight management computer of their Boeing 747-400. A similar product, FANS A, was developed by Airbus for their A340 and A330 aircraft. Together, the two products are collectively known as FANS 1A. Operator benefits offered by FANS include reduced fuel burn and flight time through direct routing, and increased payload capability for takeoff weight-limited flights. As mentioned before, errors in navigation and potential errors in voice communication between the flight crew and air traffic control help determine the necessary separation between airplanes. That means aircraft often operate at less than optimal altitudes and speeds. However, through a satellite data link, airplanes equipped with FANS can transmit automatic dependent surveillance reports with actual position and intent information at least every 5 minutes. The position is based on the highly accurate GPS. Digital data communication between the flight crew and the air traffic controller drastically reduces the possibility of error. The combination of improvements in communication, navigation, and surveillance allows authorities to reduce separation distances between airplanes, which in turn allows airplanes to fly at their optimum altitude and burn less fuel. Oceanic operations currently are based on weather data that is 12 to 18 hours old. By using the satellite data link that is part of FANS, the latest weather data can be transmitted to an airplane while it is en route. Flight crews can then use this data to develop optimized flight plans, or those plans can be generated on the ground and transmitted to the airplane. Such dynamic rerouting may allow airlines to consider reducing discretionary fuel, which further reduces fuel burn or allows an increase in payload. Satellite communication can reduce response time from what is currently 20 to 60 minutes down to a few minutes. An airplane requesting a step climb to a new optimum altitude can get clearance much sooner, reducing fuel burn. To avoid potential conflict, an airplane that is approaching crossing tracks must be separated by altitude from any traffic on another track. As a result, one of the two airplanes can be forced to operate as much as 4,000 feet below optimum altitude. But if the air traffic controller has timely surveillance data, including projected intent, and the airplane is able to control its speed so that it reaches the crossing point at a given time, altitude separation would be required less frequently. In many cases, current air traffic routes are compromised to take advantage of existing navigation aids and radar coverage, resulting in less than optimum routes. Taking advantage of space-based navigation and communication would allow more direct routes. With fans in place, operators could benefit from reduced fuel burn and flight time, as well as increased payload capacity for takeoff weight-limited flights. As a result, costs associated with crew and engine maintenance could be reduced, allowing operators to apply the money saved toward implementing and operating new routes. The fans concept improves communication, navigation, and surveillance. Communication improvements involve a transition from voice communications to digital communications. Specifically, ACARS was used as the communication medium. This allowed other application improvements. Controller-Pilot Data Link Communications, or CPDLC, allows the flight crew to select from a menu of standard ATC communications, send the message, and receive a response. A peer application exists on the ground for the air traffic controller. ATC can select from a set of messages and send communications to the airplane. The flight crew will respond with a Wilco, standby, or unable. The current standard for message delivery is under 60 seconds one way. Navigation improvements involve a transition from radio aids and inertial navigation to satellite navigation using GPS satellites. Surveillance improvements involve a transition from voice reports based on inertial position to automatic digital reports. The application is known as Automatic Dependent Surveillance Contract, or ADSC. In this system, an air traffic controller can set up a contract with the airplane's navigational system to automatically send a position report on a specified periodic basis, every 5 minutes, for example. The controller can also set up a deviation contract, which would automatically send a report if a certain lateral deviation was exceeded. These contracts are set up between ATC and the aircraft's systems so that the flight crew has no workload associated with setup. The required components for your FANS 1A system include the following: a Unilink airborne data link. There are two models. The UL800 requires an external VHF data radio, whereas the UL801 contains an embedded VDR. Also required is a universal FMS with a control display unit. The CDU is the interface between the pilot and Unilink. Other components include FANS visual enunciators and a FANS oral alerting device, a cockpit voice recorder to record CPDLC and FANS messages and events, and an approved SATCOM system to support remote oceanic FANS CPDLC communications. FANS 1A is principally composed of 3 applications. Controller-Pilot Data Link Communications allow data link messages to substitute for traditional voice communications for routine communications between a crew and an air traffic controller. CPDLC messages can be used to request and grant clearances, to inform the ground of the aircraft's position and situation, and to provide instructions to the crew. Air Traffic Services Facilities Notification allows the aircraft and an ATS provider on the ground to exchange addresses, as well as information about which FANS applications they support. Automatic Dependent Surveillance Contract requires no crew action. ADSC allows ATS providers to query the aircraft to provide position reports and other situational data at regular intervals, or in response to events specified by the ATS provider, such as a change in altitude or lateral deviation. Crews that operate this system must be trained and obtain operational approval from the state of registry. These familiarization videos do not constitute certified training. For such training, contact Air Training International or COBEV International. However, These familiarization videos do provide visual examples and demonstrations of performing the functions described in your operator's manual.